6.2 Law of Cosines. So we've got our cosine formulas at the top of these notes that you've already printed out and you're ready to go. So let's go ahead and jump into our first example. Oh, and before we even start that, one of the things that's super exciting about Law of Cosines is there's no way you're going to get two triangles. So, which is super nice. You don't even have to worry about it. One of the other indicators for Law of Cosines is that we don't have any pairs. So it's not like I have a pair of A's or a pair of B's. You'll notice that nothing pairs up. I've got small a, small b, and small c. So we decide, and I think I want to find angle A first. So to find angle A, I am going to do a squared is equal to b squared plus c squared. So it starts out kind of looking like the Pythagorean theorem, which is kind of nice. Minus, here's where it gets weird, 2 times b times c cosine, don't forget this is law of cosine, so you are going to use cosine, of angle A. That's what we're looking for. Alright, so I'm going to do the same thing that I always do. I'm going to manipulate the equation first. It's not until the end I'm going to grab my calculator. So let's go ahead and subtract the 32 squared and the 15 squared. Again, not grabbing my calculator yet. I'm just bringing down what I have. Alright, I'm trying to get A, which means I think now I have to divide, because that negative 2, 32, and 15 are all being multiplied. Alright. And I think I'm going to get rid of the parentheses, and I'm just going to use dots now. So negative 2 times 32 times 15 equals cosine A. Alright, last thing I need to do is inverse cosine this thing. Alright, there's angle A. It's kind of ugly, but now if I can communicate well with my calculator, I can type in exactly what I see here. Although I need to put in a couple extra parentheses just to make sure that I tell the calculator exactly what I want it to do. So I'm going to add in 2 more sets of parentheses just to ensure that the entire numerator stays together and the entire denominator stays together. If you then type in exactly what we've written, you will get the correct answer. So I'm going to put parentheses around the top so it stays together, and then I'm going to put parentheses around the bottom so it stays together. So I'm going to type in exactly what I have written down. No different. Inverse cosine, open a set of parentheses. Now you're in the numerator. Open a set of parentheses. Type in the numerator. Close the parentheses. Hit the divide sign. Open the set of parentheses for the bottom. Type in the bottom. Close the parentheses for the bottom, and then close the parentheses for the entire thing. And then hit equals and see what you get. It's kind of nice if you get used to typing things in all at once. So angle A, when I typed it in, I got 143.9334 degrees. Now I don't know if I'm going to need this or not, so I store just in case. All right, I'm going to go through and do the exact same procedure, and I'm going to find B. So I'm going to pause right now. I'm going to fill it all in for B, show all of my work, but this would give you an opportunity to practice and see if you can find it as well. Okay, so I went through, showed all of my steps. I think I actually put 1 or 2 steps together. And then I ended up with 24.7493. The last thing I need to do, and I stored everything in buttons just because I'm not sure if I'm going to need it or not. And if you don't store it now, you're kind of stuck later. You're going to have to redo it all over again. So the last thing I need to find, I think, is angle C. And I'm not going to do law of cosines again. I'm just going to go through and do triangle sum this time. So it's going to be 180 minus angle A, which I starred in A, and angle B, which I stored in B. If I type this in, I think I get that C is 11.3172. And there are my 3 answers for this. And I don't need to store C because I'm definitely not going to be using it again. Now let's take a look at example number 2. Example 2 is just a little tiny bit different. Notice that you still don't have any pairs. You've got a big angle A and you've got a little b and a little c, so two little sides. All right, so nothing matches, definitely not law of sines. And based off of what we have, the only thing that we can find is little a. So let's go ahead and get that set up. So plugging it into my formula. And cosine of, and the angle that was given to me was 115. Okay, this is actually much nicer than trying to find an angle. All we need to do is type this whole thing in and then square root it. So make sure that you square root that whole mess. Now for me, because I don't like how many parentheses I think this requires, I type in everything inside the square root all at once, and then I hit equals, and then I square root that answer. So I'm just not comfortable at that point with having so many, well, what I think is way too many parentheses. So, and I'm sure you probably could do it without, I just, I kind of go overboard on them sometimes. So in this case, when I type this in, I get 21.2552. Not degrees, this is a side. I am going to store it as A because chances are I'm probably going to need it again. All right, now at this point I can find angle B or angle C, it doesn't really matter. So I'm going to find angle B. So to find angle B, I'm going to go ahead and set it up, and it's just like the previous example. So now would be a good time to pause, see if you can set this up and solve it, and look for angle B. Okay, so I went ahead and set up for B, and then I manipulated the equation. You'll notice that I lost more steps this time, so I'm going to go straight to the punch on this. And then I type it in, and it looks like B, I get 39.7611. Highlighting my A as well. So let's see, I've got a pair of A's, I have a pair of B's, and I'm missing C. Well, to find angle C, all I have to do is triangle sum. So to find angle C, I'll do 180 minus angle A, which was given to me as 115, minus angle B, which I just found, and I stored it as angle B. If I go ahead and type that in, I believe I get 25.2388 degrees. Go ahead and highlight that since that's one of the things I'm looking for. And then I believe in this example we're also going to practice a little bit of area, or we may as well. So if I want to find the area of this, remember that you can find use whatever area formula you want. So I think I'm still going to go ahead and use what I have. But look at the originals. I've got little b, little c, and big A. Let's just use all the originals. So half BC sine A. Remember that the area of the oblique triangles is going to be sine, not cosine. And go ahead and type this in and let's see what we get. Okay, so there's the area that I got, 67.9730, just following what I typed in. All right, let's go to the next slide. And I think example 3 is just a little bit of practice of Heron's formula. So to be able to find, or to use Heron's formula, we need to be able to find S. So let's find S first. So S is the sum of A, B, and C all divided by 2. So it's not quite average, because with average we would have divided by 3. No, this is dividing by 2. So if I type that in, I think my S is going to end up being 18. Now I'm just going to go ahead and plug it into the big old formula. So area, let's move down because I need a big square root also. It's going to be big square root. I'll erase them if I don't need it. Is going to be S times S minus A, which was 11, times S minus B, times s minus c. Oh, fits perfectly. Go ahead and type this in. And it looks like, at least when I typed it in, the area that I got was approximately 54.9909. And that's it for 6.2.